welcome guys. So this video, we will talk about Compton effect and prove the two famous formula in the general physics or in modern physics. So yeah, the first formula is this, and the second formula, yeah, I think is this one. Okay. So don't worry, I already write down every note, each equation. So we'll not waste your guys' time, and I will do it step by step. So yeah, so don't worry, I will do equation by equation. Okay, so starting point is that you have a photon, right? And with the frequency f, and you hit some free electron. So this free electron is assumed to be classical. So somehow like what I mean classical is that this electron can be stay. So it's a particle, and your light hit it, and your lights deviate with some angle theta, and your electron deviate with some phi angle, and the frequency become hf prime. And then we want to prove that the wavelength difference lambda prime minus lambda will be h divided by MEC, which ME is electron mass, and the speed of light times 1 minus cosine. Okay. So the idea is that yeah. So now let's go to the proof. So original momentum called p gamma and p gamma prime is original photon and the after photon. So this is a momentum conservation. So I get p lambda minus p lambda prime equals pe, and then you square it, you get p lambda square, p gamma square plus p gamma prime square plus 2 times p gamma times dot p gamma prime equals p square. So momentum square. Remember that for the photon we have pc equals to hf, right? So I can write hf square plus hf prime square plus minus 2h square ff prime cosine theta, right? In the product, so there is a cosine theta. By the way, this is yeah, this vector and this vector, they are in the angle. Their angle is cosine, right? And it become pc square. So pc square is e square minus me square c to force, because this is a relativistic particle for the electron, right? So you can change it to this. Okay, so now we have this red block equals to this and equals to this. Okay, so the final is that we have already used the momentum conservation, so the rest is the energy conservation, right? So what is the original energy? Original energy is hf, and the light is hf prime, right? So the total energy difference will be hf minus hf prime plus MEC square. This MEC square is the static mass, static energy for the electron. So in original you have hf and MEC square, right? And the final you get hf prime. So the rest of electron energy will be hf minus hf prime plus MEC square. Square minus MEC to the c square times c to the 4th. So you get this equation. So this guy, right? This guy expanded contains 6 terms, right? So you get a very long term equals to the left hand side, right? Okay, so now you do the expansion. So you get the hf square plus h square prime square. You get this large expression. Okay, amazingly, you see, you can cancel this term and this term, this term, this term. Cancel all of it, you get this. And then this term will cancel with these terms, right? So finally you get this. And you need to do it carefully, but you can follow my step. You get 2h square ff prime, 1 minus cosine prime, and 2 MEC square f minus f prime h. And you cancel h, and 1h you get here this, and delete 2. And then you get the c divided by f prime minus c divided by f equals h divided by MEC 1 minus cosine. And yeah, so the wavelength times the frequency will be the speed of light. So this will be lambda prime minus lambda equals h divided by MEC 1 minus cosine. Yeah. So all the proof details are given here, and you just do it step by step, right? And the most difficult thing is there are a lot of terms, and you just cancel one by one. Okay. Tired. Okay, so the next is that so another formula people like to see is that if you know the angle of the electron, at least phi angle, then what information you can get, right? So the answer will be this cotangent phi will be tangent theta divided by 2 times this hf divided by MEC squared plus 1. right? So this is another formula. You can find this formula at Wikipedia, but Wikipedia do not give the proof of this formula. Okay, but I will give the proof. Don't worry. Okay, so the proof idea is that we want to get this angle phi, right? So we first what else we can do, right? We get phi, right? So the momentum conservation at the y direction tell you that Pe sine phi equals P gamma prime sine theta, and the momentum conservation and the axis give you P gamma minus P gamma prime cosine theta equals Pe cosine phi, right? So if you use the first equation divided by second equation, you get tangent phi equals P gamma prime sine theta, P gamma minus P gamma prime cosine theta, right? So you get this. And so tangent phi, right, and you use definition, this P will be HC divided by lambda, also the HF divided by C. You get sine theta divided by lambda prime, 1 minus lambda minus cosine theta divided by lambda prime. So clearly you get lambda sine, lambda prime minus lambda cosine, right? So lambda sine, and use formula that replace this lambda prime by the first formula. You get lambda plus MEC cos minus 1 minus cosine minus lambda cosine. So the amazing thing is that this term and this term can be combined and give you another 1 minus cosine term, right? So you can give it become this. By the way, you divided lambda from the denominator and numerator. So finally, you get tangent phi equals to sine theta 1 minus cosine times HF plus MEC squared plus 1. And then you flip the equation, right? So it becomes cotangent phi 1 plus HF divided by MEC squared times tangent theta divided by 2. Okay, so this is the two important formula in the Compton effect, and all the derivation are given here. So hope you guys like this video. Be sure to subscribe to my channel and click the like button before I will click the like button. I will see you guys in the next video.